Power over Ethernet is a technology utilized in professional surveillance systems, wireless networks, voice networks, and other applications. Welcome to my channel. My name is Steve. In this video, I'll provide helpful background information and other details on PoE, which you may find useful as you design and install a network. Power over Ethernet is a system that safely transfers both electrical power and data signals to a remote device. It does this using a standard LAN cable, also known as a network cable. Low-power versions of PoE can operate over Cat5 cable, but higher power versions require better cable like Cat6 or Cat7. The IEEE standards for PoE emphasize safety. There are means in place to ensure that electrical power is sent in a safe and reliable fashion. Terms like PSE and PD are used when discussing PoE technology. PSE stands for Power Sourcing Equipment. This is the device that provides the power in a PoE network. It may be an end-span PSE located at the end of an Ethernet link segment, or it may be a mid-span PSE located in the middle of an Ethernet link segment. A PoE switch is considered an end-span PSE. Here are some examples from various manufacturers. PoE switches are available in many shapes and sizes. Form factor, port count, feature options, and management capabilities are some of the considerations to be addressed when selecting switches for a particular network. A PoE injector is considered a mid-span PSE because it is located in the middle of an Ethernet link segment. Here are some examples from various manufacturers. An injector receives the Ethernet signal from an upstream Ethernet switch and overlays DC power on the cable. A traditional injector will have two ports, in and out. However, multi-port injectors are also available, such as the device shown here. PD stands for Powered Device. This is the device that draws power from the PSE. Common PDs include IP cameras, wireless access points, and IP telephones. A standards-compliant PD will present a signature in its hardware to the PSE. Without that signature, the PSE will not apply power to the cable. This safety feature will be discussed later in this video. The IEEE 802.3 standard supports Ethernet links of 100 meters from transmitter to receiver. The location of the midspan has no bearing on this, as the midspan device does not terminate and regenerate the Ethernet signal. It's considered to be a pass-through. There are 8 wires or conductors in a network LAN cable terminated with an RJ45 connector at each end. They are organized into 4 twisted pairs. At 10/100 speeds, 2 of the 4 pairs carry the data. Pairs 1-2 and 3-6. Pairs 4-5 and 7-8 are not used. At higher speeds like gigabit, 2.5 gigabit, 5 gigabit, and 10 gigabits per second over copper, all 4 pairs carry data signals. Before 2003, there were no standards for power over Ethernet. Some manufacturers used their own proprietary implementations, but interoperability was not guaranteed. In 2003, the IEEE ratified the first PoE standard, 802.3AF. This defined what's called a PoE Type 1. PoE Type 2 was defined in the 2009 standard, 802.3AT. Some refer to this as PoE+. PoE Types 3 and 4 were defined in the 2018 standard, 802.3BT. Some refer to this as PoE++. PoE Type 1 per AF supports 15.4 watts of power at the PSE port. It does this by using an output voltage of 44 to 57 volts DC with a maximum current of 350 milliamps. On long Ethernet cables, there will be attenuation, which is reduction in the amplitude or the signal strength as it passes along the wire. The AF standard takes this into account and ensures at least 12.95 watts available for the PD at the far end of the 100-meter cable. The standard allows for operation on Cat3 cable, but recommends Cat5 or better. The standard specifies 2 of the 4 pairs in the cable to carry the DC power. PoE Type 2, per the AT standard, supports maximum power at the PSE port of 30 watts by using an output voltage of 50 to 57 volts DC and a maximum current of 600 milliamps. This ensures at least 25.5 watts of power available for the PD at the far end of the cable. The AT standard allows for operation on Cat5 cable, but recommends Cat5e or better. This standard also specifies 2 of the 4 pairs in the cable to carry the DC power. PoE Type 3 and Type 4 are defined by the 802.3 BT standard. PoE Type 3 supports 60 watts at the PSE port, ensuring 51 watts are available at the far end of the cable for the PD. PoE Type 4 supports 90 watts at the PSE port, ensuring 71.3 watts are available at the PD. All 4 pairs are utilized to provide this power. BT not only supports gigabit speeds, but also newer multi-gig speeds like 2.5 gigabit, 5 gigabit, and 10 gigabits per second over copper. PoE Type 3 and Type 4 require Cat5e cable or better for proper operation. With higher power levels, the heat generated in the cable bundles becomes more of a consideration. To minimize any potential thermal issues, better quality cable like Cat6a or Cat7 is recommended. The AF and AT standards support 2 different types of powering, Alternative A and Alternative B. Both alternatives use 2 of the 4 pairs in the LAN cable to carry the DC power. With Alternative A, the PSE applies the DC power to twisted pairs 1, 2, and 3, 6. With Alternative B, the PSE applies the power to twisted pairs 4, 5, and 7, 8. To be compliant with standards, a PSE may support either method. A PD, however, must support both methods. This ensures interoperability regardless of which method is utilized. Phantom power is the technology that allows the DC power to be carried on the same electrical conductor that's also carrying the Ethernet data signal. A 10100 network following Alternative A utilizes phantom power on pairs 1, 2, and 3, 6. Pairs 4, 5, and 7, 8 are not used. A 10100 network following Alternative B does not utilize phantom power. Data signals are carried on pairs 1, 2, and 3, 6, while DC power is applied to pairs 4, 5, and 7, 8. A gigabit network following Alternative A utilizes phantom power on pairs 1, 2, and 3, 6. Pairs 4, 5, and 7, 8 carry data signals only. A gigabit network following Alternative B utilizes phantom power on pairs 4, 5, and 7, 8. Pairs 1, 2, and 3, 6 carry data signals only. Networks following the BT standard with 4-pair power over Ethernet utilize phantom power on all 4 pairs. The PoE startup process begins with signature detection. During signature detection, the PSE seeks the presence of a PD by sending an electrical pulse down the cable, looking for a specific resistance signature. If successful, the PSE knows it's connected to a valid PD and proceeds to apply the DC power. Should a person touch the RJ45 electrical contacts with their fingers, the PSE would not apply the DC power because the specific PD signature is missing. This is one of the safety aspects built into the IEEE standards. After signature detection and power application to the PD, an optional process called classification occurs. During classification, the PSE attempts to determine the lowest power level that can be mutually supported by itself and the PD. This may be done in the physical layer or by using link layer discovery protocol. This table shows the different PoE classes defined by the IEEE standards. As an example, an IP camera may classify itself as Class 2. In such case, the PSE will only reserve 7 watts on this port from its overall PoE budget. Note that if a PD fails to classify itself, the PSE will default the port to Class 0, reserving 15.4 watts for the PD. Even after applying power, a PSE will continually monitor the link to ensure the PD is still connected. A compliant PD must draw certain current to avoid being disconnected. This minimum current is called maintain power signature. For example, a PoE-powered LED light may shut off automatically at night. The PD's MPS feature informs the PSE that the light must remain powered so it can sense motion and turn back on at any time. The 802.3 BT standard adds an option for dual signature PD. A dual signature PD has 2 independent detection signatures, classification signatures, and maintain power signatures on each pair set. Consider an IP camera, for example, with a separate heater and pan-tilt zoom motor. It may be advantageous to utilize signature system 1 for the heater and a different signature system 2 for the lens motor. PoE technology provides flexibility to position end devices like IP cameras and wireless access points in locations where it's otherwise hard to reach with power. For example, a security system professional may be installing surveillance cameras in a warehouse with a tall ceiling. The cameras need power, and there is no AC in close proximity to the camera locations. The security professional may hire an electrician to install AC drops for each camera. But this can be costly. The better option is to use power over Ethernet and simply connect each camera to a PoE switch port with a LAN cable. Outdoor installations are further challenging when AC power is involved. Safety becomes a major consideration. But since PoE is considered a low-voltage application, it's very simple and straightforward to power outdoor devices and avoid the hazards of outdoor AC. Because only a single cable is needed for each device, AC to DC power adapters are eliminated, which minimizes cable clutter and further simplifies the network. LAN cables are easy to relocate. Should it be necessary to move an end device like camera or access point to a different location, it's easy to do by simply moving the cable. Because devices are powered through the LAN cable, reboots are a simple matter of unplugging the cable from the PoE switch and then plugging back in again. Most business-class wireless access points can be powered by PoE. This allows placement of access points in strategic and otherwise hard-to-reach locations. When selecting a PoE switch for wireless applications, be mindful of the uplink speed on the access point. With modern Wi-Fi 6 and Wi-Fi 7 access points, the uplink port speed may be greater than 1 gigabit. In these cases, be sure to select a PoE switch with appropriate interfaces. IP surveillance is the most common PoE application in the security industry. Most business-class surveillance cameras are powered using PoE. Cameras are connected directly to the PoE switch, which is also networked to the video management software and network storage drives. Businesses of all types use PoE-powered phones. VLANs may be used to keep the voice traffic separate from the general data traffic on the corporate network. Using PoE for controlling access into rooms and buildings eliminates the need to have AC power and expensive AC power backup at each door location. Simply power the PoE switch with an uninterruptible power supply, and all doors and badge readers remain operational, even in the event of a general power failure. PoE-powered clocks are ideal for school classrooms, hospitals, and business buildings. Each clock requires a single LAN cable from the PoE switch to provide its power and timing synchronization. There is no need for AC power at each clock location, nor is there a requirement for batteries. The PoE switch is also connected to a master clock or network time protocol server, which can either be on the local network or connected through the internet. This NTP server ensures all clocks are synchronized, showing accurate time, and automatically adjusts during changes such as daylight savings. PoE-powered LED lights are suitable for both commercial and residential applications. These special LED lights receive power directly from a PoE switch, eliminating the need for AC power in ceilings. They are energy efficient and can be tuned to various color temperatures. They are ideal for new construction and smart buildings. Because PoE is considered a low-voltage application, there is no need for conduits, and the lighting can be installed and set up by the same team that installs the network cabling. In this example, the small 5-port PoE switch in the middle of the diagram is not powered by AC, but rather receives its power from the PoE switch 100 meters upstream. The incoming power is sufficient for the switch to operate normally. There is also surplus power available that can be further propagated downstream to 1 or 2 PDs. Utilizing PoE in such a manner effectively doubles the Ethernet distance limitation from 100 meters to 200 meters. Many PoE switch manufacturers support a feature called Extended PoE. This feature is activated on a PSE port either via a dip switch hardware setting or software setting. When activated, it allows the port to reduce data rate in exchange for additional distance. Typically, the data rate is dropped to 10 megabits per second, which allows an extended distance up to 250 meters. This is an ideal solution for IP cameras located greater than 100 meters from the PoE switch, as most IP cameras do not need bandwidth in excess of 10 megabits per second. A PoE splitter converts a PoE cable carrying both power and data into 2 separate cables, one purely power and one purely data. This allows use of a non-PoE device, like the camera shown here, in a PoE network. A typical splitter may support an output voltage of either 5, 9, or 12 volts DC. Access control, IP surveillance, IP clocks, wireless networking, LED lighting, and IP telephony are all outstanding applications for Power over Ethernet, both commercially and residentially. There are many other applications as well, including intercom systems, paging systems, public address systems, digital signage, video kiosks, environmental and industrial sensors, and more. A power budget on a PoE switch refers to the total amount of PoE power that's available to all connected devices. The power budget can be allocated across all PoE ports as needed. Different PDs will have different power requirements. Power budgets vary from PoE switch to PoE switch. Switches with higher power budgets normally have higher cost and may also require fans for cooling. When selecting a PoE switch, its PoE budget should be a top consideration. A PD may not necessarily require the maximum amount of power supported by the PSE port to which it is connected. If all connected PDs have a small power draw, a smaller budget switch may be utilized. However, if all or many connected PDs have a high power draw, then a larger budget switch would be required. Here are some examples of different PoE switches from different manufacturers. All 3 switches support 8 PoE ports, but they are very different in terms of features and functionality. The first switch, with a 64-watt PoE budget, could support 8 Class 2 devices across all 8 ports, but could only support 2 Class 4 devices. The switch in the middle column with a 160-watt budget would fare better. All 8 ports could simultaneously support Class 1, 2, and 3 devices, or it could support up to 5 Class 4 devices. The switch on the right has the largest budget at 295 watts, which is enough to support a healthy combination of Class 1 through Class 6 devices. Following is a realistic example of an 8-port switch deployed in a corporate network. Ports 1, 2, and 3 are connected to different IP cameras. The Class 1 camera requires 4 watts. The Class 2 camera requires 7 watts, and the Class 3 camera requires 15 watts of power. Port number 4 is connected to a Class 2 IP phone, which also requires 7 watts of power. Ports 5 and 6 are connected to a PC and printer. These are non-PDs, therefore they need no power from the switch. Ports 7 and 8 are connected to Class 4 wireless access points, each requiring 30 watts of power. The total required power draw sums to 93 watts. The PoE switch selected has a power budget of 160 watts, which is sufficient for this network. This also leaves a power surplus to accommodate potential changes in the future. When selecting a PoE switch, a smart managed PoE switch is often worth the extra cost over an unmanaged switch, as it provides additional features and functionality. A smart PoE switch supports the ability to configure important PoE features and parameters from anywhere at any time. There is no requirement for an IT admin to be on site. The admin simply needs VPN access into the switch in order to configure, manage, and troubleshoot it remotely. Some PoE switches can also be managed through a cloud portal. A typical graphical user interface on a smart PoE switch will show PoE system settings, such as the switch's total PoE budget, the amount of PoE power in use, and the amount of remaining PoE power. A smart PoE switch will also show port-level information, such as actual power usage on each port. The admin can also monitor the PoE classification for each PD connected to each port. In addition, the admin can assign a priority to each port, which tells the switch what to do when the PoE budget is approached or exceeded. The admin can also configure specific PoE time profiles, which enable and disable the PoE power on a per-port basis according to a specific schedule. This may be useful in a school classroom application with a requirement to shut down wireless networks during non-school hours. Perpetual PoE provides uninterrupted power to a connected PD even when the switch is rebooting. Connected devices like IP cameras and wireless access points will not lose power and reboot themselves when a PoE switch reboots at the end of a firmware upgrade, for example. Fast PoE saves the PoE power settings across a reboot. It powers on the PD once the PSE starts booting without waiting for the boot process to complete. Perpetual PoE and Fast PoE are complementary features that work independently of each other. In cases where Perpetual PoE cannot maintain uninterrupted power, such as a complete power cycle or a power failure and recovery, then Fast PoE will take over. Various PoE switch manufacturers support a PD Keep Alive feature. This feature can be activated on a PSE port either via a dip switch hardware setting or software setting. Powered devices like IP cameras and wireless access points may occasionally lock up and require reboot. The PD Keep Alive feature, when enabled, can address this automatically. An example of the process follows. A smart PoE switch sends periodic pings to a PD on a specific port at a preset interval, expecting a reply each time. If the PoE switch doesn't receive a reply within a configured number of attempts, it will cut the PoE power, then re-establish the PoE power on that port. In essence, it reboots the PD automatically should it fail to respond to regular pings. Optionally, the PoE switch may also send an SMS text message to the IT administrator noting the issue. Access control, IP surveillance, IP clocks, wireless networking, LED lighting, and IP telephony are all outstanding applications for Power over Ethernet, both commercially and residentially. PoE is an IEEE standard. This is critical for safety and interoperability. PoE saves money. It simplifies installations. With PoE, there is no need to hire an electrician. There is no need to install AC power drops for end devices like cameras and wireless access points. There is also no need for AC to DC power adapters. This minimizes cable clutter and keeps the network simple. PoE is a low-voltage technology. It can be installed by the network cabling team. When selecting a PoE switch, be mindful of PoE power budgets. This is one of the most critical features in a switch. Choose the right budget for your present and future needs. Select a smart PoE switch rather than an unmanaged PoE switch. The added features and benefits are compelling and outweigh the minimal cost increases. I hope you found this information beneficial. Please like and subscribe for more content like this.